that's going to help us understand the linked list operations based off of these function prototypes. So these are the first things we include, the reprocessor flags. We're going to need that in the program. And this is going to be the structure of the nodes of the linked lists. It's going to have a number and then pointer to the next one. Now this is literally the structure of a singly linked list. Now this is the function prototypes: create node up to insert after value. Yeah, and then as usual the code starts running from the main function. So we're initializing the head to be null, the int, the choice, and the data. The choice is going to be from one of these options here, 1 to 5. Then the data is going to be the data we're going to feed in when we're working with append, prepend, delete by key, all these. Yeah. So we have a switch case statement here. It's going to handle all the cases 1 to 5. So let's say you entered case 1. We have print list here. What does the print list function look like? It's here. Void print list. So this function literally returns a null pointer, like void, returns nothing. And it takes a head pointer as an argument. So since we don't want to lose the link to the head, that's what we're going to do first. We're going to assign a temporary pointer to the head, and that's what we're going to use to iterate through the whole list. So this print and this print is just for formatting, just to make it look nice. And then so while temp is not equal to null, print the value of the current node and then switch the node to the next one. So this while loop is going to run until we reach a null pointer. Yeah. Then also, since this is not amongst the options, create node is a function that's going to create a node and then return it. So struct node, the point is going to return a pointer for type struct node, and it's going to take an argument for a number. So we're initializing the node here with malloc. Malloc is going to help us create memory for the node. Then we're going to assign the value of that current node to the number we have passed, then the next pointer to null, as we're going to assign that during append or prepend, then we're going to return it. So yeah, that was print and create node. Then case 2, this is append. See, so append also returns nothing. It takes 2 arguments, a double pointer to the head and a number. So here, when we're adding a node at the end of the list. So we're going to first create that node, this function create node, and then now we're going to check if the head is null, meaning if the list is empty, it has no nodes so far, then we're going to just assign the head to the new node. Otherwise, if the list is not empty, this line here is going to help us. Remember, like I said in the print function, this helps us not to lose the link to the head. So while temp is greater than or equal to next is not equal to null. So here we're iterating through the list until we reach the last one. Now you notice in the print function we iterated with temp is not equal to null, but here we're using temp is like as long as the next pointer for the current temp is not equal to null, meaning if we did it like we did in the print function, we wouldn't be able to do this because then the pointer would be null. But since we're ending on just like on the very last one, we're able to do this. Yeah, I really hope you've understood that. Okay, that was append. So after checking all this, reaching the last one, then we're going to assign the last one of the next one, the one we have just created. That's append. Then I'm going to show you the practicals after explaining all this. So it was case 2, you enter value, the value is entered into data, then append works, then yeah. Then case 3, now we're dealing with prepend. Now prepend does the opposite of append. Append appends at the end of the list, prepend appends at the beginning of the list. So just like append, it takes a double pointer and returns nothing, and also takes a value that we're going that's for that method we're going to prepend. So this line you've already seen is just creating a node. You're creating a node memory. Now, what this line is doing is, since we want um, this new node to be at the beginning of the list, the one we have just created, we're going to assign its next value to the current head, and then we're going to change the head to point to this one we have just created. Hope that makes sense, but that's what these two lines are doing. Also notice when you're accessing a struct through a pointer, it has to be this, not a dot. Yeah, sometimes not as well. And also note that here we're using double pointers, not single pointers, because if you were to use a single pointer, then you'd be working with local memory. And remember, this node is supposed to hold a pointer. Like each node is supposed to hold a pointer, not a local variable. Yeah, that was prepend, and then delete by value, and I'm going to explain delete by value and delete by key at the same time. Now, in the context of this work, we have this node has only a number and a next pointer. So delete by value and delete by key usually have the same implementation, because if we had maybe a key like int key here, then it would be somewhat different, but literally the same thing in this work. So delete by key by value, then delete by key. So delete by key also returns nothing, it takes the pointer to the head, then the key. Now in value it's going to be a value, but it's literally the same implementation. There's no confusion, at least in this work. So here we're initializing temp to point head and then previous to point. Now we're going to choose previous, that's below here. Now what we first check, if the value you want to delete is the head, we can't just delete it, because if we delete it, then we would have access to the linked list. So if the value we want to delete is the head, we shift the head to point to the next one of the one we want to delete, like the first one, then we free it, then we get out of it. Otherwise, if it's not the head, then this loop is going to run until it finds the key that we're looking for. And it's also making sure we are not at like the very end of the list. So yeah, we're assigning previous to temp, then temp to the next one of the one that has the key we want to delete. And what this checks is if what we want to delete doesn't exist. That's what this is checking, meaning if we reach at the very end of the list, then just get out of the function. Otherwise, if it's there, then we want to change the previous node's next pointer to point to the one after the one we want to delete. That's what this is doing, and that's the purpose of previous here, to hold the one just before the one we delete. That's how that makes sense. Now free here is going to free the memory for the one we want to delete. Yeah, delete by value, same implementation literally. Now amongst these options we don't have insert by key and insert after value and insert after key, so I'm just going to explain those independently. So insert after key, it's going to be the same notation as insert by value based on the context of this. Yeah, let this all not confuse you. So this is also going to return nothing. It's going to take a double pointer to the head. It's going to hold a key and a value. So imagine You already understand this. We don't want to lose the connection to the head. Now, here, we're going to just search until we reach what we're looking for. Since it is sought after key, we're going to look until the value of the node is what we're looking for. This key, like it matches. That's what this while loop is doing. Then if it's not there, like if that key is not there, just get out of the function. Otherwise, if it's there, we're going to create a new node. Now, since this is insert after key, the next one for the new node is going to be the next one for the current node. And then the current node, the next one of the current node is going to be the node that we've just created. Now, I hope that doesn't confuse you, but yeah, that is literally the same implementation as insert after value. Just complete it. Then list operations. So those are the options we have. If we print the list now, it's going to be empty. Yeah. Let's say we want to append something, enter value to append. Let's say we append 200. Then we print the list. And it has 200. Okay, let's append another one. It's option 2. 300 this time. Print the list. Yeah, see it's after that. Now, if you want to prepend, that's putting at the beginning. Interval, let's enter 4000. Then print the list. See now 4000 at the start. Let me prepend one more. Option 3 and 5000. Then I print the list. See at the beginning. Now let's say I want to delete 5000. So option delete value to delete 5000. Print the list. Ta-da! It's gone. So this brackets again, I said the code will just make it look nice. The way you see here. Yeah. So then option 5 to exit and